Hello, welcome to Advanced Wireless Troubleshooting Section 3. Today we're going to talk about once a client gets into the run state, what are some of the issues he may run into? Now, what is the run state? The run state basically means that we've completed every security process. We got IP addresses so the client knows his IP address. We passed all authentication and we're in our final state. Basically, we can pass traffic through the controller. Now, what are some of the things that could happen that may kick that client back out of the run state? In other words, have him drop off the network. Well, you can have AP radio events. So you can have radio disconnects due to a radio resetting. You can have issues with abnormal resets. So here I use the command show history interface, .11 radio all reset. It gives me basically the radio reset reasons and timestamps, how many clients were affected, and what slot it was doing, slot buying if it's the 2.4 radio or 5 gig radio. If you're using DFS channels, be aware of radar events. If we detect radar, we have to basically go silent and change channels. So again, that's going to go ahead and kick your clients off. High channel RF utilization. Now here we have a high channel load of 42 based on the QBSS information element. You'll notice we got an error. It says not beaconing for too long. So remember that the AP radio has to play nice with all wireless clients just like everyone else. He has to listen before he transmits. If our RF utilization is so high or channel utilization is high, I can't beacon. Well, because Cisco Wireless tries to be as self-healing as possible, the code is set up that it looks and says, well, hey, I haven't beaconed for a long time. Maybe there's something wrong on the radio firmware side. I'll go ahead and reset him so that maybe that will clear the issue. Now that resetting, that's going to knock any clients off. Here's an example of high RF utilization in my lab. This is a GUI. This is on 2.4. In my lab, basically 2.4 is only good for microwaving popcorn anymore. It's pretty noisy there. 5 gig's good though. So you could have a high duty cycle. So this is channelizer. So if you notice that big red stripe on the 2.4, that right there is somebody who basically is constantly transmitting. Now you might think of, well, who's going to always be transmitting? Well, you could have issues with video clients. Maybe it's a surveillance camera that's always transmitting all the time. Maybe it's not even using your radios, but it's using your same band to its own private connection for the surveillance cameras. In which case, it doesn't matter if it's your AP or somebody else's AP. If they're on your channel, they're on your channel. If they're always transmitting and with a high duty cycle, it's going to affect you. So you might want to think to yourself, how exactly do I figure out if I'm running into the RF issues? I have buildings scattered all over the place. In fact, I have remote sites all over the place. Well, a really clever guy wrote this tool called the WLC Config Analyzer. That analyzer basically takes a output of a show run config and basically, which has a ton of information in it, and basically parses it into a readable format. A lot of our advanced services guys provide a lot of feedback for additions on this tool. This tool has been worked on now for the last several years, with each iteration adding more and more features to it. It's really slick. It runs on Windows only, unfortunately. So if you're a Mac user, we have an alternate that you could use. It's not as detailed as this one, but it should help. The best way to get a show run config, I tell people, is just to do the transfer upload of the controller support bundle. Inside that support bundle will be a full show run config. Okay, that's going to give you all the data that you need to feed into this tool to give you all this information. You can see here the 2.4 band is not in the best shape. So you have a lot of areas where you have close to zero. On this, because these are scaled metrics, the higher the number, the better it is. As the number gets lower, that's worse. So what are some other issues that might creep up? Well, you could have an idle timeout that's idling out your users. Or you could have a session timeout. Remember, the session time is going to be the absolute length of time that that authenticated session is good for. You could have a WLAN change. Maybe you went in there and changed something on the WLAN and hit apply. Well, in the background, what that guy's doing is he's disabling the WLAN, applying the settings, and re-enabling the WLAN. Well, if you've disabled that WLAN, all those clients that are connected to that WLAN are de-authenticated. You can have AP radio resets due to power or channel change. Maybe you have RRM running in the middle of the day. And in the middle of the day, it decides, hey, these APs need to change channels and or change power. Well, those clients are going to get kicked off. Or maybe you just manually de-authenticated them. Broadcast key rotation timeout. Every hour, we rotate the broadcast key. Remember, every client has two keys. He has a unicast key and a broadcast group key. That broadcast group key is shared by all clients that are connected to that same AP. When we're rotating that key, we have to basically tell the client, hey, here's your new key, and he has to acknowledge it. If we don't get an acknowledgement, we'll retransmit. If we still don't get an acknowledgement, we'll de-auth him. So remember in section 2, we went through all those with the debug client. Here's a really cool tool that's available online that you can upload the output from a debug client. And it doesn't matter if you're using 10 MAC addresses and they're all jumbled together and whatnot. You can just say group by client MAC, and you can literally look at each and every client and see what happened here. Like for this guy, he wasn't responding to our M1 with his M2. So we de-authenticated him. But it lays it out in English and tells you the plain reason what might be going on. Now here for your Mac users, here's sort of the lightweight version of the WLC config analyzer. So it doesn't have all the bells and whistles, but it does give you a lot of really good information about RF health metrics. And honestly, if you wanted to have a successful wireless deployment, your RF health should be one of your top priorities. If you've got good RF health, that's like half the battle, even probably 75% of the battle right there. Because remember, you're using unlicensed spectrum. Think about New York City, where you have a skyscraper and every other floor is a different company. They're all using their APs. Well, they run into problems with connecting, so what's the first thing they think? I'll just crank up the power, which makes everything worse. So a lot of times getting good RF health, it's really key to a happy user environment. So again, key ideas here. So clients can be removed for a number of reasons. Best to start with a client debug. Sometimes you have to do a packet capture, an over-the-air packet capture, and always remember to look at your radio status or RF conditions. That can really tell you a lot. So let's move on to Flex Connect clients. So remember early we talked about the split MAC architecture. Well, you can see here that we have a Flex Mode AP that's doing central off and central switching. But you'll notice because he's Flex Mode, he's also now handling the association request and response. But he's going to the controller for authentication, and all the data is going to the controller. Now let's flip it a little bit. Same Flex Mode AP, but now I'm doing local auth and local switching. you'll notice now the AP is handling everything. It's only notifying the controller about the client. You have so much flexibility in a flex mode AP. You could say, hey, I want to do local switching, but I want to do central DHCP. I want my DHCP request to go to the controller. You have a lot of flexibility in how you set that up. So debugging for Flex Connect. We're going to concentrate on cause APs. In the PDF, there's actually some for your reference that talk about debugging on iOS APs. But for now, we're going to concentrate on cause. What is cause? Cause is really Cisco OS. It's a Linux-based operating system that runs on all 802.11ac Wave 2 APs and above. We have a lot of show commands on cause APs. We have lots of options for the show Flex Connect. We can see the client, see his MAC address, association ID. Is he in a forwarding state? What encryption is he doing? Any type of AAA overrides? Who handled his association? Who handled his auth? Am I switching centrally or locally? Here, my show Flex Connect WLAN. I can see my radio and my VAP. VAP is like a virtual AP. So every SSID will get assigned a new VAP. So here we have, even though it's on the same radio, we have VAP1 and VAP2. They're two different SSIDs. The VAPs are important because you'll have to know those when you run some other commands in a couple slides here. So you'll see that show.11 clients onboarding .11.0 WLAN 1, that's really VAP. So there is talking about the ones that were for the Cisco Live B, which basically was my 2.4 radio. Here I can do show FlexNet client AAA override and give you an idea of what type of AAA overrides are being applied to what clients. Here's show FlexConnect MCAST. That gives an idea of all of our FlexConnect multicast information, because remember, when you're doing your Flex APs with local switching, then he's participating in all the multicast stuff, just like if he was a switch connected to another switch. So you have your groups, what's learned, your reports, what clients are interested in what groups, all that's listed there. We have our show.11 clients. I included this one specifically because it shows our RSSI for the clients connected to and the max rate that he can connect at. So remember, your data rate's going to change sometimes from packet to packet. What this is telling you is what maximum rate that client can connect at. We want to know the IP address that the AP learned from the client. We can do show data path client IP table. We want to know what are the last 100 reasons why clients got deauth. We can do the show.11 clients deauthenticated, get an idea of why they're deauthenticated, why they got kicked off. Show FlexNext client exclusion gives us our client exclusion list. Here I manually excluded a particular client on the controller. It got pushed down to this Flex AP. Again, this also shows you the WLAN VLAN. That shows us our VAP. Remember that we talked about before, and also what VLAN it's mapped to. So the client debug, just like the controller has a client debug, cause has a client debug. Client debug is a macro that enables what's called client traces. Client traces is how you basically run debugs on a cause AP. Now, debugs can vary based on AP chipset vendor. So typically your debug client's going to be the one you use, but for some of the 1800 series, you'll probably be using a debug.11 client commands. So let's look at the debug client walkthrough here. So you can see that we got an authentication message coming in. So you see that U and W. So that means it came up from a client received on a wireless interface. You'll see we're responding by a D message. DW means it's going down to the client via the wireless interface. Here you can see a UW, we got an association request, and a DW, we responded to the association request. We create our add mobile ID, our association ID. And since this was a pre-shared key, we move it from associate to 802.1x. Now you'll notice we're doing our keying. So it's going down to the client, up from the client, down from the client, up from the client. Now we have our encryption key. So now we can plumb those keys into the radio for that client. Now we've moved to IP learn pending. Now you'll notice that we got a ARP query came up from the client. He wants to know who is 192.168.1.1. So you notice this U and E. E is the Ethernet interface. When it's U, that means it's going up to the switch. When it's D, that means it's coming down from the switch. So there you see the ARP query. The ARP query gets forwarded on the Ethernet. The switch responds back. It comes down off the Ethernet. Now you'll notice that we also now learned the IP address via the ARP request that the client sent us because we see sender. So now we're moving from IP learn pending into the forwarding state. Now here's an example of DHCP. You have your request, you have your reply, and then you have your ACK. Remember, he already learned this IP address here. He's already into forwarding because he learned it via the ARP. He still did his DHCP later on though, but he requested the same IP address that he already had. He didn't do a discover and then got an offer. He just did a request, or like a half DHCP request. That's how I like to call it. So let's look at a debug client where the client gets disassociated. Here I just turned off the radio on my phone. The phone sent a disassociate. You notice we received it from the client. We notify the WLC that the client's going away. We move the client from forwarding state to delete pending, and then we send him a response. So let's talk about client roaming. So client roaming, the definition, it's a set of steps taken by a client to move from one AP to another. It's really as simple as that. So it's whatever the client's going to do. Is he going to scan other channels to find some place to roam to? He's going to select somebody to go to. He's going to do his off, his association or reassociation, and any type of optional 802.1x or DHCP. The main rule is roaming is always a client-side decision. The infrastructure can influence it by setting varying things. You know, power levels, RF design, RX SOP, optimized roaming, all those things can influence, but ultimately it's a client makes the choice. He makes the choice of where to go and when to go. So what could trigger a client to want to go? Well, he might be seeing poor RSSI. He might be missing beacons from the AP or packet errors. Perhaps he got a 11V BSS transition request. That does not mean he has to honor it. Client implementations can be so very different. And every installation of roaming has timers associated with it. Every client can be different. So let's take a look at roaming patterns here. So we're going from the star on the left to the star on the right. The red dots are APs. So we're coming up here and we're kind of far away from the other AP, but we got that wall in the way that's blocking that other AP. You could potentially run into some roaming issues there. Packet loss, you know, if you're on a voice call, you might get choppy audio. Well, how could you maximize things to try and prevent that? Basically, moving the AP over. So now he's got a clear path from one AP to the other AP to the third AP. Again, I always recommend doing a site survey. If you're going to be doing voice, a voice survey. They are different. Even replacing APs one for one, I always recommend do a validation survey afterwards. Different APs, it could have different power levels. They could be newer. The FCC could have changed things as far as allowed powers for different things. Lots of things could have changed. Do yourself a favor, get a validation survey after you've installed new APs. So security, remember, any new connection must always comply with security policy. So if we're doing 802.1x, every time he roams, he has to do 802.1x. Now, of course, if we're caching keys, that can help. CCKM, PMKID, 11R, fast transition, all those are going to help avoid delays in roaming. Just to remember, here's all the exchange we have to do when we're going off to the radius server. Now look at the packet flow for CCKM. From this to this, it's a lot less. Even fast transition, which is the standard now for key caching, or fast roaming, if you will. You can see far less. Over the DS, it's a little bit more packets there. I always recommend doing the over the air. It's just simpler. Sometimes with protocols, simple is better. And over the DS or over the air, I think is the best one. It's actually, I believe, a default now. We made a change for that. So let's look at some debugs from here. So we have our management frame off. So we know we're doing pre-auth. We know we're doing it over the air. We got an AKM. The AKM matches with a PMK cache entry. We have the 11R roam client. We're moving the mobile into a fourth auth state. We're skipping the EAP success because we don't need to. All we're doing is doing the keying. You'll notice now we change from 802.1x required to L2 auth complete. So from there, we're into essentially the run state. One thing to note about over the DS, it is not supported on Mobility Express. So if you're doing any Mobility Express deployments, do not do over the DS, only do over the air. And that's the end of this section. Thank you very much.